do you think it's possible to power vertical farms when demand for energy is lower? So looking at maybe sort of powering through the night rather than through the day. Um, would this work from a sort of a plant physiology and a crop physiology perspective?
So as Jim's just said, that there is a massive power draw from powering these vertical farms. But the advantage is that it's already electrified, right? So we're not having to use fossil fuels to drive this. We can directly plug into the renewable energy grid as it comes online. Now, the downside of renewable energy sources is they're much more varied during the day. And as Jen's alluded to, what we need to do is sort of correlate the energy drain required for vertical farming to when the energy is available from the grid. Now, the good news is that plants have evolved, they have adapted to growing in these fluctuating environments. And what we've shown in the lab already is that plants grow better when you grow them under these varied fluctuating conditions. So the trick's going to be to line up when that energy is available to when the plant can best use it. And that's what we're actively trying to do now. And we're working with the energy providers as well to try and synchronize energy demands on the farm with what the plants need at certain times of day.
And Matt, from the UAE's perspective, like, obviously, you know, you're a journalist sort of working with a UAE-based newspaper. The GCC states have been very early adopters of this technology. I think you described them as cathedrals to plant growing to me in a call that we had recently. I'd be really interested to hear about sort of your thoughts on energy use within sort of the UAE and GCC states. We don't have the same sort of drivers to reduce our energy use in terms of the economic costs that we do here in Europe. So what's going on in these states?
Well, maybe not the same drivers, but there certainly is a drive in the Gulf states to reduce carbon footprint as the world moves away from hydrocarbons. And in terms of vertical farming, of course, high energy usage. I think I saw a report which said that it takes nearly 39 kilowatt hours to produce 1 kilogram of produce in a vertical farm, which is about 7 times what it does in traditional farming. So anything that can move the industry towards renewables, to use renewables to get the energy into vertical farming would be great. I mean, firms like Bowery in the States are already starting to do this. And the desire in the Gulf states will be the same, because they all recognize that one day hydrocarbons are going to run out and they're not going to make money from it then. So why not invest that money now in sustainable energy?
That's great. So we've got that movement throughout the world. It's not just where hydrocarbon-based energy is expensive, that we've got that drive towards a greener source of energy to power these facilities. Moving on to sort of things like transport and logistics, Krista, that's your sort of area of expertise. How do you think vertical farming changes how you'd think about moving food around and how you manage that supply chain? It's like thinking from sort of the site of original production through to sort of like the final consumer. And then how can that then also have an impact on the carbon footprint?
So firstly, your supply chain and logistics is a really crucial part of your components. A lot of companies now are looking at their Scope 3 emissions, which are really important. And with vertical farming, the biggest benefit you have is control over the location of production. And this enables us to much better optimize the logistics system. So I think now a lot of companies and the hauliers themselves are thinking about, they've got deadlines to meet in terms of phasing out emitting vehicles. They're looking to electric trucks. And at the same time, and to facilitate those electric trucks, they're having to really focus on their logistics systems and optimize them beyond what they've had to do before. Because I think we've been lucky before. We haven't needed to optimize so much because energy was cheap. Things are much more expensive now, and the vehicles are expensive, electric trucks, the energy is expensive, so we need to optimize it now. And this is something that can reduce the transport distances, and also a lot of this will be cold chain related, and so minimizing the amount of time that it has to be chilled or frozen, whatever the case may be. So that's a huge advantage. Linked to location, of course, is also onshoring some of the produce that is currently being imported. So I think in the UK, something like 50% of our fresh veg, 90% of our fresh fruit is imported. So if some small slice of that can be onshored, that's obviously a huge reduction in the carbon emissions associated with the shipping or the air freight and the refrigeration associated with that. And then one final point just to add there, talking about electric trucks and things. I think they speak very nicely to all of this in that we will need to optimize the system for these trucks because they have slightly more limited range. It's much more difficult to integrate into normal logistics systems. And so with the control you have around vertical farming, around the timing of harvest and production and all of that, it speaks much better to an electrified freight system of the future, which is great.
And so just following on to that electrified freight system, would you see a need to integrate sort of like vehicle charging alongside vertical farm points so that essentially like when you're picking up your sort of topping up your vehicle as well?
Yes. So this is something, charging infrastructure associated with electric trucks is a big discussion point at the moment. Businesses are struggling to understand, do they need depot charging for the vehicles overnight? Do they need to take opportunity charge while loading or unloading? Do they need to charge at public rest stop sites, for example, during mandatory driver rest breaks? So there's a big question around that, but charging during loading and unloading is certainly going to be one important component of that. And that would integrate nicely with, the higher predictability with vertical farming. I would just say, though, that with increasing levels of automation, both within the vertical farming space and just logistics in general, and the automation of vehicles, that opportunity to charge during loading and unloading is going to reduce. And so that opportunity will diminish ultimately towards zero at some point in the future. So it's something to be aware of.
And Matt, do you see like this change to food logistics having an impact on sort of like food losses and waste in the system? That's a huge sort of like carbon sink really that we don't see as a consumer.
Yeah, so I think all of the logistics we're talking about are not necessarily going to change consumer behavior too much. But following on from what the previous roundtable was saying, we need to stop doing 2-for-1 offers and go more into using partners such as Fair Share to sort of take that surplus food and take it where it's most needed. When it comes to minimizing waste within the supply chain, though, as Chris has just alluded to, we are simplifying and shortening the supply chain. And that's going to either increase consumer choice, so consumers can choose exactly what they want to buy at the right time. That will minimize loss. Of course, because those food chains are shorter, that means that the produce will be a lot fresher, so it will stay at home in consumers' fridges for a lot longer. And so the other benefit of vertical farming is that we have a lot more control within the actual pre-harvest stage, where we can apply certain light treatments to prolong shelf life actually before we harvest as well. So that's an additional benefit that there is. So overall, by simplifying down the supply chain, we're just increasing consumer choice and then extending shelf life.
And so, Jim, within the vertical farm itself, like building on that sort of idea of reducing our food losses, is there anything that we can do in the growing process that enables us to reduce these losses further?
Yeah, I think there's abundant opportunity. I think vertical farms face a sort of agronomy problem as well as a genetics problem, in as much as we don't really know much about how to do the agronomy, the growing very effectively. It's all been done outdoors in glass or in glass houses before where the sunlight's free. This is a completely different environment. And the genetics are all designed, so the kind of plant varieties are all designed to be grown outdoors or under glass, so again, not for vertical farms. So we can think of different ways of managing these wastes. So one way would be, for instance, outdoor grown crops are already adapted to have shorter, smaller root zones. So we could potentially take some of those kind of adaptations indoors. Another area is use of environments and light. So a good example of that would be you can put blue light on a plant, and it tends to make it a bit more compact. More red light would tend to make it a taller plant. compact plants are quite good in vertical farms, but the consequence is that you tend to get longer roots, which may not be helpful to us as we've got kind of lots of material moving around the farm, potentially, kind of dirt and damage there. One other area is potentially pruning. I mean, we're quite familiar with outdoor pruning of, kind of perennial crops, but perhaps we should be pruning roots. And there may actually be, we've certainly seen it in chives on our farm. If you cut the roots a little bit, the stress actually causes increased shoot growth. So there's lots of opportunities there. The other difficulty with the sort of root waste is that we're not very sure at the moment of the kind of the streams that come out, what we can do with them. So there's things like biochar that we could make, and they have an energy benefit potentially, and that way you'd also potentially capture some of the carbon and lock it away. So helping the reduction in overall emissions. So that'd be quite an advantage. But you've also got the roots are not alone; they're mixed in with a load of substrates, and substrates are potentially a difficult area for vertical farms. At the moment, peat's been phased out because peat's bad. But instead, we're just shipping in coir, which is a kind of coconut husk. But the kind of the market for that is only quite limited, and if we're shipping thousands and thousands and thousands, millions of tons of this stuff from the Far East, we've just created another problem. So we've got to deal with these substrates. So part of it also is kind of thinking upstream, is like, what sort of substrates can we use to avoid having giant amounts of transport miles and huge amounts of organic waste coming out of the system. So perhaps it's in recyclable, reusable substrates as well, which we're also working on. They have an end-of-life problem. They're often made of polylactic acid, so they look like a plant-based material, but they're fundamentally a plastic. How are we going to get rid of them at the end of their lives? So there's lots and lots of interrelated problems there. I guess my summary would be, we need to start with sensible design at the start, and carefully managed and thought through waste streams at the end. And I think we're a long way from that overall as an industry at the moment. We're kind of working on it, but the infrastructure isn't currently there.
And are there sort of like shelf life opportunities within sort of the growing process as well? Like, sort of we see, I mean, if you look at your average pack of basil or chives or whatever that you buy from your local supermarket, they'll have a typical shelf life of maybe 5-6 days. Like,
Yeah.
Are there opportunities here to extend that out further, just through the sort of the process of localizing supply, but also the growing?
Yeah, so the abundant opportunities. So Matt alluded to that just now. So our challenge is to try and extend shelf life, and it's extremely straightforward to do that in a vertical farm. So we're already confident for most of our crops, for sort of leafy veg, that we can get well past 7, 8, 9 days, often up to 11 days, and sometimes up to 15 days of shelf life, with a quality that you'd expect on the shelf. And this transforms the way that consumers experience vegetables. They can potentially be packed and processed in different ways. They might not need to be wrapped in PP and polypropylene quite the same way they are at the moment. It also transforms the way that supermarkets manage stock. They can change the way the supply chain works, and they don't need to keep quite so much just-in-time stock available, because potentially the shelves will be fuller for longer. So there's abundant opportunities there. And for sort of the import substitution side of it, if you imagine a basil being flown in from Kenya, it's harvested, 24 hours later it's on the plane, 24 hours later it's in the UK, 24 hours later it's in the shops. So that's 3 days of shelf life consumed in the transportation process. If we can locate, next to a distribution centre, for instance, we could potentially be on the shelves in 12 to 24 hours. Again, it takes a giant chunk of the potential shelf life out. So there's huge, huge opportunities there, and it really transforms the way we might experience food.
Chris, within the sort of the logistics process that obviously is going to have to go alongside vertical farms, is there an opportunity here as well to reduce food and crop losses just through the sort of the process of transport?
There are a number of opportunities. So the obvious ones are, just through reducing the amount of time that this is in transit makes a big difference. But also I think not a lot of interest has been like on the transit itself. So obviously we work in the trucking space, and some of our fresh produce is coming in from rural Africa, for example. And I was actually in Uganda a few months ago, monitoring the kind of loads that tomatoes experience getting from the farm in rural area outside of Kampala back into the town. And, you know, these are not necessarily very well maintained vehicles, not necessarily very well maintained roads, and there's a lot of loss in that process. You know, you've got about like 100 kilograms of tomatoes in a big wooden crate. By the end of that process, all those tomatoes on the sides of the crate, at the bottom of the crate, are basically either discarded or some other use for tomato sauces and things. So there's a lot of work to be done there in, for example, sustainable packaging, but done in a sustainable way that uses local waste produce that's available at the farms, and that can be constructed with a fairly low skill set. And I think there's a lot of opportunity in that space.
Cool. So I think from what the panel have said, there's a lot of opportunity. There's a lot of areas where we could reduce our carbon impact. And I know this is a net zero carbon sort of focused event today, but I wanted to sort of think forward. Like once we've nailed carbon, Matt, what do you think are the next challenges?
You're talking about water, aren't you? And this is where vertical farming comes into its own. And it's also why places like the Gulf states are so interested in vertical farming, and why some of the world's biggest vertical farms are in UAE and Saudi Arabia. And it's because they can save 90 to 95% of the water. It's literally growing food in the desert. It may be a closed environment agriculture, but it's growing food in places that don't have easy access to water, or, you know, water is difficult and it has to go through desalination, and et cetera, et cetera. So what the water, as well as the reducing your carbon footprint, the water, of course, is a very big environmental issue in itself. And by recycling water, by capturing the evaporated water from the crops, vertical farming proves that you can farm certain crops efficiently, more efficiently than actually growing them in the soil, with almost the minimum amount of water.
Jim, Matt, as two plant biologists on this panel, what do you think? Like, where do you think vertical farming can have these impacts on water use? Like, what are the almost like the low-hanging fruit here?
So, as Matt says, one of the key benefits of vertical farming is that we're working with a sealed system, right? So, if you have a sealed system, you can recycle a lot of the chemicals you need to apply. So, be that fertilizer or pesticide, you can just add minute amounts of that and then recycle and repurpose it as need be. Of course, that has great benefits for minimizing pollution as well as minimizing the cost of actually adding input into the system in the first place. So once we've solved this energy problem, which is involved in heating and providing the lights, then everything else sort of comes along quite naturally. So minimizing water use, chemical use, all of that is cut down quite easily.
Yeah, just to make a couple of points. One thing for vertical farming is really you are sparing land potentially, which makes a huge difference. So you have other opportunities to use land in different ways. Now, whether that be in additional, space for humans, or returning some previously agricultural land to more natural environments or differently managed environments, shall we say. I'd make one sort of other point, which is when we talk about sustainability, people often forget about the UN sustainability SDGs, and there are 17 of those, and carbon emissions-based SDGs. There are only 3 of those. I think that's industry and innovation, responsible consumption and production, and one other that's just slipped my mind. There's tons of other SDGs out there, and if you think about the example of crops being shipped from Africa, for instance, if you shifted that balance of production and substituted the imports into with the UK-based production, you might have profound impacts on the Sustainable Development Goals. They might actually be positive. So there's a paper, I think, from 2017 that looked at some of this. But they would include, zero hunger, no poverty, life underwater, life on land, gender equality. I mean, there's almost all the other Sustainable Development Goals fit around our choices that we make. I think vertical farming actually could be very positive for this, possibly because it might allow farmers in developing nations to change their access to land, access to the best land, and their ability to produce crops for local consumption, as opposed to working as potentially landless labourers for products that get flown to the UK. So that might be a very profound change to the way that perhaps some developing nations experience kind of agriculture. Might well be positive, but I don't know.
Thanks, Jim. That was actually, when it comes to the sort of like the questions that I wanted to ask you and how sort of facilitating this discussion, I think that's quite a good way to end, is thinking about the UN SDGs. So I think we've got a couple of minutes left. Yeah, 1 or 2 minutes left. If anybody's got any questions they'd like to ask. So gentleman on the front here.
Quick question. Sorry, my name's Steve Tudley-Folson. I'm from Alliance, advise startups, including some in vertical farming. I'm interested about the amount of waste. So I know some people are working on how to take some of the waste, the stuff that isn't sold as food, and then turn it back into energy to reduce the input costs to the vertical farm. Is that something that interests you? Do you have plans to do that sort of thing?
Hand over to Jim.
So yeah, as I sort of alluded to, you could take some of the wastes and you can burn them. You can do pyrolysis and create biochar, which is probably a slightly preferable method, because then you do lock away some of the carbon. So that's potential. I mean, to my mind, what you want to try and do is, think about the kind of, can we reuse them first of all? And then secondly, can we recycle them? And thirdly, can we just get something useful out of them at the end? So probably if you're burning them, you're at the sort of third stage of what's kind of desirable, but it may be your only option. That's what I don't know if that answers your question, but we're working on it, I think, is the answer. We know we have these wastes. We know we need to deal with the waste streams. We can't just dump them in the ground. So what are we going to do with it? But we've also captured a lot of carbon, so there is a real opportunity there.
Can I? Oh, it is, yeah. Can I just change tack and just ask a question around affordability, if I can? Because currently the headwinds are cost of living crisis, cost of capital's going up, cost of energy's generally record sort of highs. What is the current cost premium, cost of production premium of this technology over conventional? And what do you think the timeline is that it'll start navigating towards parity?
I didn't quite hear the question, sorry.
So the question was, what's the timeline in terms of cost of production to bring it on parity with sort of current traditional methods of agriculture?
I could go on this.
I'm going to... Matt?
So maybe the professionals who are actually running vertical farms can answer this better than me, but from the collaborators that I talk to in industry, it depends on the crop. Some crops are already grown at about the same price as you would for field-grown crops. That tends to be for higher value crops, so it can be quite niche. And so the key is going to be continued optimization so that we can grow these lower margin products and more efficiently to become more competitive. But it is happening. It just varies on a crop by crop basis.
Yes, but I guess the other thing I would say is that I think if you imagine what Dell did to desktop computing in the 1990s, where they took apart the process entirely and worked out how they could do each element of the process better, quicker, cheaper, that's really where we're at the vertical farming at the moment. So we're competitive on some premium price products. It's a long way from being competitive on an iceberg lettuce, and this is just for leafy greens. But as we optimize the process, there are giant gains to be made in optimization of lighting, as Matt's alluded to. The numbers are absolutely stupid, so I won't bother to quote them because you won't believe me. But it's tens of percentage point gains in efficiency from different lighting conditions and using them effectively.
So just for instance, just quickly, we were able to increase yield by 20% just by changing when we gave the light energy. So simply by changing the timing of giving the same amount of energy, So there are huge optimizations to be made.
Enormous optimizations possible. And that will, again, if you can cut the cost of production by 10 or 20% a year, even for 5 years, it really transforms what the range of possibilities is for products that you can profitably grow.
And just as a closing note, it's probably worth highlighting that there's actually quite a lot of vertically farmed produce available in the UK already that you may not realise that it's coming from vertical farms. I think it's approximately 30% of the basil that's eaten in this country is produced in vertical farms already. It's just not highlighted that it is. So you're already at price parity because you're already buying it. Likewise, like retailers like Iceland have recently launched ranges of vertically farmed produce, which is selling through Iceland stores, who are known to be good value, sort of like regular person's supermarket. It's not, they're not trading at a high price point, and so people are doing it, and it's just a case of making sure that best practice gets throughout the whole sector. I think that's all we've got time for on our session. I'd like to thank the panel, particularly Matt for flying all the way down from Glasgow today. Apologies for your carbon footprint there. But thank you very much, all of you, for attending. If you've got any further questions or you want to discuss anything with the rest of the panel, we'll be around the show for the rest of the day. So please come and find us or connect with us through the app. Thank you.
Thank you very much for this.